Yes, today we are going to discuss the grade 10 lessons. I hope you have already watched our grade 11 videos. This is the grade 10 video. Today we are going to mainly focus on chemistry, the basic concept of chemistry. It is unit 3 in grade 10 lesson. The main topic is structure of matter. What is matter? You know in smaller grades that you have learned about matter. For example, all the things in the world can be divided into many types. For example, if a biologist is doing this classification, he will divide all the things in the world. Now let's say all the things in the world. Everything which is present in the world can be divided according to living, non-living, living things, non-living things, or else it can be divided as microscopic or macroscopic. But today we are going to see how the chemists are going to divide this into. So according to chemistry, we have two categories. The first one is, in this category, the things which fall into this category, they occupy space. They occupy space and have a mass. The thing which does not occupy space, no space, and does not have a specific mass. We know in smaller grades we have learned that anything which occupies space and has a mass is called as, yes, matter. The things which do not occupy space and do not have a mass are called as energy. Yes, now this is the topic. We will be talking about energy mainly in physics. We have a lot of energy, light energy, sound energy, about waves, and all the things we'll be studying it under physics. Under chemistry we'll be mainly targeting matter. Matter can be divided into many topics. For example, you will be learning as pure substance and mixtures. Pure substance and mixtures. Pure substance can be further divided into elements, pure elements, and compounds. Pure element, for example, hydrogen, helium, lithium, beryllium, boron, whatever element, whatever we call as atoms. Pure atoms are considered as pure substance and element. Under compound, two or more atoms join together. For example, carbon and oxygen will join to form carbon dioxide, CO2. C is an element, O is an element, H is an element. C and O will join to form a pure compound, carbon dioxide. Hydrogen and oxygen will join to form H2O, water, pure compound. Likewise, under mixtures, mixtures also can be divided into two. First one, homogeneous mixture. Homogeneous mixture and heterogeneous mixture. Homogeneous mixtures are mixtures which have same amount of substances, same physical properties, same concentration at any point of the given substance. That you will be learning in grade 11. If you have a liquid and this liquid, the concentration, the density The chemical, physical, all the properties are same at each point. At point A, point B, point C, if the chemical, physical and biological properties are similar, it is called as homogeneous. Homo means same. Same here, same here, same. Therefore, same type of mixture. The other type of mixture is heterogeneous mixture. In a heterogeneous mixture, if you take a heterogeneous mixture, liquid heterogeneous mixture, point A, point B, point C, there will be differences in their density, in their color, in their transparency, in their consistency, in their concentration. Therefore, chemical, physical and biological properties at point A will be different to point B, at point B will be different to point C. Therefore, different. Hetero means different. So, heterogeneous mixtures. We will be mainly speaking about homogeneous mixture and heterogeneous mixture in the grade 11 lessons. According to our local syllabus, it comes under grade 11. Elements and compounds will be discussing it in this chapter, in the grade 10 chemistry chapter. Yes, this is one type of classification. The next type of classification of matter is depending on their arrangement. Depending on the arrangement of the atom. We know that all the things in the world are made up of atoms. Very minute particles called atom. They join to form all the substance in the world. So, in a solid substance, the atoms are tightly packed. I think you can see it in this diagram that the atoms are very tightly packed. They cannot move freely. They can only vibrate. They cannot move freely. Therefore, it is called solids. Solids have a definite shape and a definite volume. You have already studied this in grade 6, 7 and 8 and even in 9. But this is the basic chemistry. To understand the periodic table and all the other things, you should know the basic concepts of chemistry. So, when atoms are loosely packed, that is liquid. When the atoms are loosely packed, it is called liquid. The atoms can move over each other. When it is given a force or when it is shaken, the atoms can move over each other. Therefore, they do not have a specific shape. Liquids normally take the shape of the container. If you pour the liquid into a bottle, it's the bottle shape. It takes the bottle shape. If you pour it into a bucket, it takes the shape of the bucket. So, it does not have a specific shape. When you consider the volume, yes, it has a specific volume. Solid, specific shape, specific volume. Definite shape, definite volume. Liquid, no definite volume, shape, but have a definite volume. Then when you take gases, now see the gases are freely moving. Here you have to give a force to move them. But here, automatically, without any external force, without us giving any force, automatically it can move. Gases, we know that if I open a cylinder here, the cylinder's gas will spread to this whole. So likewise, gases can move freely. So, gases do not have a definite shape and they do not have a definite volume. Gases take the shape of the container and the volume of the container. So this is the basic thing about matter. So this solid, liquid, gas are called as states of matter. An object at a time will be at one state of matter. We can change the state of matter from one to the other. How can we do it? There are two factors affecting it according to our local O-level: temperature and pressure. Temperature and pressure are two factors which can change the state of matter of a substance. For example, the best example is about water. Water at room temperature, it is liquid. You can pour it into a glass. It is called as water. Okay. If you freeze the water, it forms ice cubes. So ice is a solid state of water. Water is the liquid state of water, and once you heat it or evaporate it, normally if you heat it by giving heat, it turns into vapor, water vapor or steam, water vapor or steam. And when you once you heat it and it comes to this position, it tries to escape, it tries to move away. So this is steam or vapor, water vapor. So one substance can have any of the given state of matter depending on the temperature or pressure. So I have ice. What should I do to the ice to convert it from ice to water? Yes, increase the temperature. Once you increase the temperature, ice, solid, will become liquid. The point which ice turns into water, it is called the, yes, melting point. Solid changing to liquid is called the melting point. Normally we consider the melting point of water as 0 degrees Celsius. For other metals, for other liquids, for other gases or other substances, the melting point differs. This is for water. Yes. Now, if I want to convert this water, liquid, into gas, that is steam or vapor, what should I do? Yes, increase the temperature. Keep it in the stove or keep it in the boiler and boil it. What will happen? This water will be converted to steam. The point which water converts to steam or liquid turns into gas is called the boiling point. Specifically, if you take water, the boiling point of water is 100 degrees Celsius. I hope you have understood this thing. Solid turning into liquid by increasing the temperature, and liquid turning into gas by increasing the temperature. Then what about pressure? Pressure is totally the opposite of that. If you want to convert ice into water, you have to reduce the pressure. Reduce the pressure. If you want to convert water into steam, you have to reduce the pressure. Pressure should be reduced. Temperature should be increased or pressure should be reduced. You should take it the other way. If you want to convert a gas into liquid, you have to, what happens to the temperature? You have to reduce the temperature of the gas, then it will become liquid. When you reduce the temperature of liquid, it will become solid. When you take pressure from steam or from gas, when you increase the pressure, it becomes water. When you increase the pressure from water, it turns into ice. So I hope you have understood with this small example how the state of matter changes when you change the temperature and the pressure. So I hope you all have a clear idea about solid, liquid and gases. Solids, atoms are tightly packed. Liquid, atoms are loosely packed. Gases, the atoms are freely moving. Therefore they have a definite shape, they have a definite volume. They do not have a definite shape, but they have a definite volume. These gases, they do not have a definite volume, they do not have a definite shape. Therefore, in further lessons we will be learning about the other characteristics of matters. Our next topic is atoms and subatomic particles. How did this concept of atom arise? According to history, they say that in 460 BC, a very long time ago, a Greek philosopher called Democritus brought up this concept of atom. For example, the explanation what he gave was, if you take, for example, take a piece of paper and tear it into half, and the remaining half, again you tear it into half, then you will get a portion. Tear that into half, you will get another portion. You keep on tearing, you will go until you will go to a position where you cannot tear it further or you cannot cut it further. This specific point he considered as atom. It was a very simple thing, because according to his language, Tommy or Tom means to cut. Atom means atom or atomy means not to cut or cannot cut. So he said something which cannot be cut further, something which cannot be divided further is considered as atom. Because this was a very simple thing, people did not give much importance to this. So therefore, for around 1000 years, this was just a name. Later, Sir John Dalton, English scientist called John Dalton, he made postulates about atoms. These postulates were later disproved by Einstein, but at that time, what Sir John Dalton did made the other scientists to think. According to Sir John Dalton, he said yes, atom is one of the basic things. Atoms cannot be created, cannot be destroyed, atoms cannot be divided, something like that. He came to that extent. But what he said or what he did made the other scientists want to do more research on the topic atom. So later on, these are the main scientists. Later on, Mr. J.J. Thomson, scientist called J.J. Thomson, he did a research. He took a cathode ray tube, CRT, cathode ray tube, and connected it to a high voltage current supply, high voltage electric current supply, and vacuumed and reduced the pressure of this CRT by making it vacuum. High voltage and low pressure. When he was increasing the voltage gradually and reducing the pressure gradually, what happened? He saw some tiny particles which could move from one place to the other place. In advanced level, you will learn more about this. In O levels, ordinary level, we have in grade 10 we have a very simple idea about this. This small particle which was like light, this traveled from this electrode to the other electrode. Yes. Then he found out that atoms have tiny other particles. Yes. And when he kept a positive charge here, when he kept a positive charge, what happened to this ray? This ray started to bend and get attracted towards this positive charge. When he changed the charge, when he kept a negative charge, what happened? These particles got repelled. When the positive charge was there, it got attracted. When the negative charge was there, it got repelled. Therefore, can you guess the charge of this particle? When it was positive, it got attracted. When it was negative, it got repelled. Yes, very good. Then this particle should be a negative particle. Because negative and positive gets attracted, negative and negative gets repelled. Therefore, J.J. Thomson, the scientist J.J. Thomson, found out a negatively charged particle within the atom, and he named that particle as electron. A negative particle which is present inside the atom. This was what J.J. Thomson found. Next we are going to talk about Ernest Rutherford. He was the next scientist. He also did an experiment, maybe with a cathode ray tube, and he found that there was another particle which was traveling like the previous one, but this was different. When a negative charge was kept, the particle which was traveling straight turned towards it. It was attracted towards the negative particle. When this charge was changed into a positive charge, these particles got repelled. Can you guess what type of charge does this particle have? Positive, getting repelled for positive and getting attracted to the negative particle. Therefore, yes, it is a negative particle. So we can say that Ernest Rutherford found out a positive particle, and he named this positive particle as protons. Next, the scientist called James Chadwick found out the next particle. He found out the particle by doing a beryllium experiment. This particle was neither negative nor positive. Therefore, it was considered to be neutral. It was considered to be neutral. That means no charge. Therefore, he named it as neutrons. Therefore, we can see that all these three particles which are present within the atom were found. So this was collectively called as subatomic particles. Subatomic particle 1, electron, found out by J.J. Thomson and having a negative charge. Subatomic particle number 2, proton, found out by Ernest Rutherford, positively charged. Subatomic particle number 3, neutron, found out by James Chadwick and neutral. It has no charge. Our next topic is structure of an atom. Now we know that scientists found out that within an atom there is proton, electrons and neutron. Then people were wondering, scientists were wondering, how is the proton, electron and neutron located? Where is it located? How is the atom? What is the structure? What is the shape? Initially, J.J. Thomson, yes, the one who found out electron, he himself brought up a theory, the first model. It was considered to be plum pudding model. The plum pudding model. According to the plum pudding model, J.J. Thomson said that the whole pudding is like the proton, and like plums embedded on the pudding, electrons are embedded in the pool of proton, which means the whole structure is made out of proton and electrons are embedded here and there on the protons, pool of proton. But this idea, he just came up with this idea. He did not do any research, nor did he do any experiments. He just came up with this idea and he named it as the plum pudding model. This does not have a scientific proof, therefore we do not talk much about this model. Second, the next person who found out the proton, Ernest Rutherford, he said he did an experiment. It is called the gold foil experiment. Gold foil or gold leaf experiment. According to his gold leaf experiment, he concluded that atom is a large structure having a center, and on that center the protons which he found out are at the center of the atom, and the electrons are somewhere scattered in the atoms and they are rotating around the around the proton. This center part was considered as the nucleus and this is the outermost part. And according to him, around 97 to 99% of an atom is made up of empty space. It is space. So later on, even this model was disproved because according to the argument of the scientists, if this is a negative particle and this is filled with positive particles, and if this is just scattered and moving, what happens if it is rotating around the proton? Gradually the negative particle will get attracted towards the positive particle and finally one day proton and electron will meet an accident. But that does not happen in real life. Protons and electrons do not collide with each other. Therefore, even this was disproved. This model was called as Planetary Model. It was called Planetary Model because it looks like the solar system. For example, the sun is the center of the solar system and the planets are revolving around the sun. Likewise, electrons are revolving around the protons. Now you can ask me one question. Yes, where is the neutrons? Why didn't we speak about the neutrons? That is because when J.J. Thomson was explaining about this model, at that time James Chadwick maybe was not born. So therefore at that time the neutrons were not found. Therefore both J.J. Thomson and Ernest Rutherford did not speak about the neutrons. Later, the final structure by Niels Bohr, the scientist Niels Bohr, he said that he further elaborated this planetary model. He said what what Ernest Rutherford said was correct, but there should be many amendments to it. For example, Niels Bohr was after James Chadwick, therefore in his theory he included even the neutrons. Therefore according to him, this is the nucleus of the atom. Nucleus of the atom consisted of protons and neutrons, positive particle and neutral particles. Therefore the center of the atom was made up of protons and neutrons according to Niels Bohr. Then electrons are scattered around the nucleus in specific pathways. For example, this is the first energy level or the first shell. First shell consists 2 electrons and they are having a specific pathway. For example, think like it is a railway track and these electrons are the trains. They keep on moving in the railway track. Therefore, they do not collide with the nucleus. Likewise, this is the second energy level. This second energy level consists of electrons and those electrons rotate. Then we have the third energy level. There are also electrons are moving. Then we have the fourth energy level. There are also electrons are moving in the specific path. So this was the final model. This model is given many names. Out of that, some call it the nuclear model, some call it the quantum model, some call it the energy level diagram. Whatever said and done, this is the final theory which we are going to study under grade 10 of local syllabus. When you further advance to to A level, you will understand that even this structure is modified into many types that you will be learning later. So for now, I hope this is enough for you to understand the structure of the periodic of the atomic model. So this was the final. Protons, electrons, neutrons all are present inside one atom, and within the atom there is a center. In that center we have protons and neutrons, and around the center we have railway tracks. First energy level, second energy level, third energy level, fourth energy level, or we can call it first shell, second shell, third shell. Each shell has specific amount of electrons rotating or revolving around the nucleus. So you might think all these structures are present within a very minute structure called the atom. Now we are going to elaborate about the fourth structure or the final structure, about Neal-Bohr structure. Now in our syllabus we are discussing about that structure and how the electrons, protons and neutrons are arranged within this structure. For example, if you consider an atom to be a sphere, I have drawn only a quarter of the sphere. This is a whole sphere, but due to lack of space I have just drawn only the quarter. So for you to understand, this is the nucleus of the atom, the centermost part of the atom. What are the subatomic particles present inside the nucleus or the center of the atom? Yes, proton and neutron. Proton and neutron. Then next to that we have the first energy level. This is the first energy level. Then we have the second energy level, third energy level, and finally the fourth energy level. First energy level is also denoted by alphabetical letter K, second energy level by L, third energy level by M, and fourth energy level by N. So K level, L level, M level and N level. Now you can see the gaps. Why have I drawn the gaps like this? It is because when you consider the energy of the energy levels, for example, this is not true values, but for you to understand I am just showing it. If I say the energy of the nucleus is 1000 joules, the energy of the first energy level will be around 1500 joules. Then the second energy level will be 1750 joules. The next one will be 1850 joules. The fourth energy level will be 1900 joules. Now tell me what is happening to the energy when going from one energy level to the other energy level. The energy is obviously increasing. 1000, 1500, 1750, 1850, 1900. These figures are just for you to understand. These are not the real figures. I am just giving you so that you will understand the concept. So you can say that the energy keeps on increasing. Yes. But what is happening to the energy gap between energy levels? The energy gap is reducing. For example, from the nucleus to the first energy level, the energy gap is 1500 and 1000. 1500 minus 1000, it is 500 joules. The energy gap between the first energy level and the second energy level, 1750 minus 1500, 250 joules. The energy gap between the third energy level and the second energy level, 1850 to 1750, 100 joules. The energy gap between fourth energy level and the third energy level, 1900 to 1800, it is 50 joules. So you can see clearly that the energy gap is slowly reducing. So these two things you all have to keep it in mind. The next thing you have to keep it in mind, it is one of the most important thing. Now we spoke about protons and electrons. Spoke about protons and neutrons. Where are the electrons? Electrons are in the specific energy levels. You just consider this like an apartment or a flat. This is the ground floor. First floor, second floor, third floor and fourth floor. First floor can accommodate only 2 people. For example, this first energy level can accommodate only 2 electrons. Second one, 8, then 18, 32. So now we all know that we have around 119 elements, the total periodic table. So when learning the total periodic table that you will be doing in grade, when you are in A levels, advanced level, or when you are doing a degree level, you will be studying all the 119 elements. When studying all the 119 elements or 120 elements, you will be considering an electronic configuration in that maximum electrons in the first energy level is 2, maximum electrons in the second energy level is 8, maximum electron in the third energy level is 18, and maximum electrons in the fourth energy level is 32. 2, 8, 18, 32. This is the actual real one. But according to the local syllabus, we have to study only about 20 elements. The first 20 elements: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium. These 20. When it comes to these 20, we don't need all this. For that 20, we need only 2, 8, 8 and 8. When doing questions in the local syllabus, consider that maximum energy level which can be stored in the first maximum electrons which can be stored in the first energy level is 2, second energy level is 8, third energy level it is 8, and fourth energy level also it is 8. Just consider this when doing questions related to grade 10 and O level. But in reality, you will be learning this in advanced level. So these 20 elements are very, very essential. So how are you going to learn all these 20 elements? Yes, our next video will be on short ways to learn the first 20 elements. We have made a song for that, so most of the students, they find it very easy to learn it in a very short method. So stay tuned. The next video will be regarding the elements of the periodic table. So I hope now you have a background idea about what matter is, what atom is, what are the subatomic particles, who found it, who found out about it, and the structure or the model of the atom. So I hope you have a clear idea by now. So students, please take down whatever notes needed. I will be checking it as soon as we meet. So please take down whatever needed things, and also keep studying, keep continuing your good work. Don't get disheartened in this period. We know that we all are facing a very hard situation these days. So don't give up on your studies. Keep studying, keep your momentum going on, and keep doing the work. Please, as a solution, as a temporary solution for this quarantine situation, we are doing these online classes. So I hope you all are enjoying these classes or have gained knowledge from these classes. So please do subscribe to our channel and get the notification by pressing the bell button, so that every new upload will be automatically shown to your YouTube channel. So please, if you like this video, you all can like the video and share it with your friends, so that even they can study while staying at home. I hope you have understood. If there is any doubt, you all can call me or you all can comment in the section below and get your doubts clarified. Thank you.